Hello everyone, welcome to our videos. Before I go further, I would like to quickly introduce you to my group. Our group name is Crocodile and consists of 5 group members including me, myself, Aida, Ami, Angel, Nisa and Berlianada. So, we are going to share with you about thermal metamorphism or contact metamorphism. Did you know what is thermal metamorphism? Let me tell you. Thermal metamorphism, or we also call as contact metamorphism, is the name given to the changes that take place when magma is injected in the surrounding solid rock. The change that occurs are greatest wherever the magma comes into contact with the rock, because the temperatures are highest at the boundary and decrease with distance from it. Around the igneous rock that formed from the cooling magma is a metamorphosed zone called a contact metamorphism area. Contact metamorphism is usually restricted to relatively shallow depth in the earth because it is only at shallow depth where there will be a large contrast in temperature between the intruding magma and the surrounding country rock.
For this slide, we will talk about cause of thermal metamorphism, or also can be called as contact metamorphism. For this, we will highlight a keyword which is contact. As you can see from the picture, the rock around the magma chamber or the intrusion of magma will break or burns the rock for it to transform or metamorphosize into metamorphic rock. This process occurs adjacent to the igneous intrusion and results from high temperature as in low pressure.
Rock types produced from contact metamorphy. First is skarn and the second is hornfels. Skarns are formed during the contact metamorphism and from a variety of metasomatic processes. Skarns tend to be rich in calcium, magnesium, iron, manganese, aluminium silicate minerals, which are also referred to as calcium silicate minerals. Hornfels is a metamorphic rock formed by the contact between the mudstone or other clay-rich rock and a hot igneous body and represent a heat-altered equivalent of the original rock. Hornfels are often fine grains. The grains are relatively small in size due to short duration of metamorphic process of cooling.
Aureole. Aureole or metamorphic aureole is a region in which country rocks surrounding an igneous intrusion have been recrystallized in response to the heat supplied by the intrusion. About the size, width of aureole vary from at least 50 meters to over 10 km wide, but it depends on the heat, size of the igneous intrusion, and the temperature difference with the wall rocks. As you can see, dikes generally have small aureoles with minimal metamorphism, but large ultramafic intrusions can have significantly thick and well-developed contact metamorphism.
There are factors affecting the size of aureole. So for country rocks, the first one is the thermal conductivity. It will control the rate at which the heat can be transferred by conduction. Next, the initial temperature within the country rocks. This, in combination with the temperature of the intrusion, will determine the initial temperature gradient, thus the rate at which heat can be flowed into surrounding country rocks. Next, the amount of water and the permeability of the surrounding country rocks. If the country rocks is permeable and contains groundwater, heat will be able to move by convection. So to the next point, intrusion. The size and the temperature of the intrusion is crucial, at which it controls how much heat is available to heat the surrounding country rocks. Lastly, so the latent heat of the crystallization of the magma. The total amount of heat available in a liquid is not only dependent on the temperature, but also involves the heat released due to crystallization. Thus, if the latent heat of the crystallization is large, there will be more heat available to heat the surrounding country rocks. And heat of the metamorphic reaction. In order for a metamorphic reaction to take place, some heat is necessary, and this heat will be absorbed by the reaction without increasing the temperature in the intrusion.